So A is in the first row, first column of this matrix. And for it to equal this matrix, then the element in this matrix has to be exactly the same as the element in this position on this matrix on the right side. So A is going to equal 5. Now the element in this position of this matrix has to be exactly the same as the element in this position of this matrix for these two matrices to be equal. So 2B has to equal -7. Likewise, this entry has to be identical to that entry, so C minus 2 has got to equal 10, and D plus 3 has got to equal 10. So A is 5, 2B is -7, which makes B equal to -7/2, or -3.5. C minus 2 has got to equal 10, D plus 3 has got to equal 10, so C has to be 12, D has to be 7. So we could call that matrix X for your variable matrix. And it needs to equal this. Maybe call it matrix Q or A or B or whatever you want to call it. They're both 2 by 2 matrices. The only way the matrices can be equal is if their dimensions, this is called the dimensions here, 2 by 2, those are called dimensions. They have to have the same dimensions, and then each element has to equal each corresponding element. Now if this is matrix X, then lowercase x sub 21 would refer to this entry or that element in the second row, first column. Matrix Q in the first row, second column, if this is capital Q, I just made that up. I could have used any capital letter other than X for this matrix here. So then I use the corresponding lowercase letter for an individual element. First row, second column. First row, second column. That's that -7 there. Okay, now you try and do number 2. All right, so we see that these 3's match up. So then 5 has got to equal 3C. -y has got to equal 7. X has got to be 4. Z has got to be 7/2. The zeros match up there, so that works. That 3A and that -9 have got to match up, and that B and that 3B have got to match up. So Z is 7/2, of course. We got that from right here, Z and 7/2. 3A, -9, the zeros match up, B equals 3B. So now we solve all these equations. We get C is 5/3, we get Y is -7, X is equal to 4. A has got to be -3, and this B equals 3B. Got to be careful with that. Some people will cancel both sides, and you end up with 1 equals 3. Well, that's not true. 1 does not equal 3. Can't have that. So what we do is we subtract. I usually subtract the smaller variable term from both sides, rather than subtracting 3B from both sides and getting a negative on the left side. I usually take the smaller of the two, 3B minus 1B. Now I got 0 equals 2B. And the only way 2 times B can equal 0 is if B is 0. 2 times 0 is 0. Number 3, have you done number 3 yet? Nope, okay. Number 3, go ahead and copy that down. That here we need to add corresponding elements. 5 plus 2, 1 plus -13. How do I know plus? Well, because of that plus sign right there. 0 plus -10, 2 plus negative 10, so I'm adding two matrices together there by adding their corresponding elements. 7, negative 12, negative 10, negative 8. Now that we've got a single matrix, now we can set each element equal to its corresponding element of the matrix on the right side. So you have 7 equals 2x plus 1, which simplifies to x equals 3. And I will give you some time to finish it up. All right, good. A lot of this is just Algebra 1 review, just in the context of matrices. We have 5z equals negative 10, so z is negative 2 for those elements right there. Oh, then let's see, negative 12, we get x is, 3. We already got x. You can double check to make sure it makes sense. Negative 4 times 3 is negative 12. 2.5 z. So that'd be negative 5 right there for 2.5 times negative 2. Minus negative 3. Well, negative 5, or minus 3 rather. Negative 5 minus 3 is negative 8. Okay, next couple problems. You want to try and find the male and female matrices that are described there, so go ahead and do that. Set up the matrices for the information shown in questions 4 and 5. There are your matrices. Male 37, 56, 0, 76, 87, 102, 6, and 27. Female numbers in their respective columns. Then you want to do the subtraction next. Males minus females. What do you think would happen if we had something like this? Try to subtract these two matrices. Abby?
Would you go by 1, 2, like on the thing, or?
Good question. It's pretty confusing, isn't it? Yes. Can't just add another column because you'd have to add another row to the first one too. So what do you think we write for an answer here when we see something like this?
You will be able
Yeah.
to.
Yeah, here you just come up with no solutions. Dimensions are not the same. Dimensions must be the same to add and subtract. Now, when we multiply matrices, we'll have a little different deal here. When we get to multiplying matrices, the dimensions don't have to be exactly the same. There is some criteria in order to multiply matrices, but having them be exactly the same is not the only criteria. There are some cases where the matrices don't have exactly the same dimensions and you can still multiply them. But we'll talk about that more when we get to multiplication of matrices. Okay, so to go back to our answer here of m minus f and what it equals, you should have gotten 14, negative 2, negative 93, negative 6, 87, 68, negative 12, negative 2. Wildling, what's up?
We put the difference, do we put negatives in because it's different?
Yeah. Yep. In the spreadsheet, you know, like Excel or something, I think you put them in parentheses, but here we're going to use negatives.